All right, for our 484 project, we did a heart disease prediction with random forests. I'm presenting along with Edward Guzman. For a project description, using heart failure prediction dataset from Kaggle, we constructed a random forest to predict heart diseases in patients. Our approach would be to randomly select a question about a specific feature at each node and grow trees without pruning. The attribute features are age, gender, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, resting EKG results, max heart rate, and exercise angina. To implement a random forest, we create each decision tree independently from each other, and for each tree at each node, we ask a question about one of the features randomly that has not been asked within that subtree. Advantages of machine learning. Cardiovascular diseases are the leading factor in deaths around the world, accounting for 17.3 million deaths annually and increasing each year. People with heart disease need early detection and management by a health professional. Machine learning is extremely useful for looking through large sets of data and identifying a new patient, whether they have heart disease or not, using previous patient data. So we used the Kaggle Dataset, which came from various places. Some observations were the same, so we had 272 duplicated observations. They were just removed from the dataset. And you can see at the bottom what an example data segment would look like. For the structure of the random forest, it consists of multiple decision trees. For our experimentation, we used 100 decision trees, but you can do as many as you'd like. So they have nodes that contain splits of the data based on a question. The leaves represent decisions for a group of points. If a tree is given a test data element, it can classify that element based on the questions. And then the random forest is an aggregate of the results of the trees. So it takes all of the decisions that each decision tree made, it adds them up, and then decides which class it is based on the majority. Here's an example. We have 3 decision trees on the left, 101, 011, 001, and then the random forest would output a 001 because for each test element, it would take the majority. Here's an example of what a decision tree might look like. Keep in mind that each question is random, and also if it's numerical, the number is also random. If it's a label, then the label it chooses is also random. And yes, that's how we ask the questions. We also compared, we used cross-validation. So we partitioned the data set into 9 sets. So 90% of it would be training data and 10% of it would be test data in each partition. And you can see that generally it has high class 1 accuracy. Class 0 accuracy was sometimes 0, which is not ideal. Class 1 accuracy was sometimes 100%, which is really good in the medical world. False positives were more frequent than false negatives, also good. And our overall results, class 0 accuracy 64%, class 1 accuracy 87%, and total accuracy was 80%. Go ahead, Edward.
Okay, so now we're going to talk about using a dropout neural network to compare results from the random forest. So for our dropout neural network, we used a single layer with a ReLU activation function, which converts string features into integers using one-hot encoding, and was done using keras. So here we see the initial dropout results with 250 epochs. And from this, we can see that loss begins to increase after a certain point, and diminishing returns at higher epochs for accuracy, and that reducing the epochs could potentially increase the accuracy and reduce the loss. So our initial output was an accuracy of only 80% with a loss of 36%. So here you can see that we've reduced the epochs to 135. So from this, we've increased the accuracy and decreased the loss, as our output is now 89% and 28% respectively. So in conclusion, with random forest, we were able to create a model that could classify whether a person has heart disease with high accuracy. We had more false positives than false negatives, which is a benefit in the medical world. We compared the results of the random forest to that of a single layer dropout model using the ReLU activation function which gave us a similar result with the best epoch being 135. That's all. Thank you for listening.